Section 7.5 talks about the product to sum and the sum to product formulas. And they are just as they say. They're changing a product. So here we have a product of trig functions, and we're changing it into a sum where we're adding them. Or down here, the sum to product, we're starting with a sum, and we're changing it to a product. So they're just exactly what they sound like. And again, working with these, we're basically going to, in this video, I'm basically going to help you just recognize the structure and then be able to apply that structure to a given problem. The first example expresses a sum. So the first thing I'm going to look for is I have a sine times a cosine. So when I look up here at all these, I see right here I have a sine times a cosine. So to make this a little bit easier on myself, I'm just going to put a little u under that one and a little v under that one. And now it's a matter of just really applying that formula. So 1/2 the sine of u plus v, so that's going to be 4 theta plus 3 theta, plus the sine of u minus v, we're going to take 4 theta minus 3 theta. And of course we can simplify that. We can have the sine of 4 plus 3 is just 7 theta, plus the sine of 4 minus 3 is just 1 theta. And there we have that simplified formula. The second example, again, I'm just looking for the structure. So I have a sine times a sine. When I look up here, I'm going to use this fourth one. And again, to make life easy on myself, I'm just going to put a little u and a little v. And now I'm just going to use this formula. So again, 1/2. But now I have the cosine of u minus v, so 3x minus x, minus the cosine of u plus v, so 3x plus x. Again, simplifying, I get 1/2 cosine of 3x minus x is 2x, minus the cosine and 3x plus x is 4x. Again, these problems are a matter of recognizing the structure and being able to apply that structure. Let's take a look now at a sum to product. So again, I'm going to look for, I have a sine minus the sine. I see it's the second one. And again, I'm going to just let this be my a and my b, and I'm going to apply this formula. So 2 times the cosine of a plus b, 5x plus 3x, over 2, times the sine of a minus b, so 5x minus 3x, over 2. And now it's a matter of simplifying that. 5x plus 3x is 8x over 2. 5x minus 3x is 2x over 2. And yes, I can simplify that again. So y equals, or sorry, no y, 2 times the cosine of 4x times the sine of x. Problem number 4 just asks us to verify this identity. Again, we have a sum. And if you notice, I have the 3t and the 5t, so my numerator follows the form of this top sine formula. So I'm just going to rewrite that as 2 times the sine of, again, this is my a and my b. So 3t plus 5t divided by 2 times the cosine of 3t minus 5t divided by 2. And then on my denominator, I have a cosine minus a cosine, so I'm going to use the last one. And again, my a and my b are the same. So this is going to be negative 2 times the sine of my a plus b is 3t plus 5t over 2 times the sine of 3t minus 5t all over 2. And again, I can simplify this, so let's just clean this up a little bit. 2 sine of 3t plus 5t divided by 2 is going to be 4t. And here I'm going to have the times the cosine of 3 minus 5 is negative 2 divided by 2 is just going to be a negative t. And then the denominator, negative 2, again I'm going to have the sine of 4t and the sine of negative t. Hopefully you see and recognize we're doing nothing but multiplying, so my 2's can cancel. and my sine of 4t can cancel. So this means I'm going to have the cosine of negative t over the negative sine of negative t. I'm hoping you remember that the cosine of negative t is actually the cosine of t. We talked about that early on in the trimester in the course. And that that's that negative, but the sine of negative t is negative sine of t. My double negatives here, of course, become a positive, so I have cosine of t over sine of t, which, as we needed to attain, I have my cotangent of t. Problem number 5 wants me to find the solutions. I could bring the negative, or the sine over, try to find when sine of 5x equals the negative sine of x. That's rather difficult, and I can't set each of those equal to 0. So basically what I want to do is I want to change this sum into a product, because once I have a product, then I can use that zero product property. So I'm going to rewrite this. Again, this is going to be my a and this is going to be my b. So I'm going to have 2 sine of 5x plus x over 2 times the cosine of 5x minus x all over 2. That's going to equal 0. Simplifying this, I get 2 times the sine of 5 plus 1 is 6 divided by 2 is 3x times the cosine of 5 minus 1 is 4 divided by 2 is cosine of 2x. Really don't need that 2. If I divide by 2, I have the sine of 3x times the cosine of 2x equals 0. Now I have two things being multiplied together, therefore one of them has to equal 0. So the sine of 3x equals 0, or the cosine of 2x equals 0. So when does the sine equal 0? 3x is going to equal 0 when the angle is 0. So and that's going to happen or at pi. So 0 plus pi n, which means if I divide both sides by 3, 0 divided by 3 is still just 0, so I just get pi over 3n. Similarly for this, one is the cosine equal to 0. The cosine is equal to 0 at pi over 2, and then again at 3 pi over 2, so pi over 2 plus pi n. But now that's 2x that's equal to that. To solve for x, I divide by 2, or multiply by 1/2. I get x equals pi over 4 plus pi over 2n. And those would be all the solutions. And finally, we have this crazy graph of the equation y equals the cosine of x minus the cosine of 3x minus the cosine of 2x. And there are 13 x-intercepts in the interval from negative 2 pi to 2 pi, and we are going to find them all. So to begin with, I'm going to recognize that I have two cosines and I have a sine. If I look at all my formulas, I recognize that I can write that sum difference as a product, and when I do that, it changes them into sine. So I'm going to do that. I'm going to take those first two and use that product or sum to product rule, which lets me write this as negative 2 sine of x plus 3x over 2 times the sine of x minus 3x over 2. And then I still have that minus sine of 2x. Simplifying, negative 2 sine of x plus 3x is 4 divided by 2, so I have a 2x times the sine of negative 2 divided by 2 is going to give me a negative x minus the sine of 2x. Now I want to take care of that negative sine of x, so just like we did up above, remember that the sine of negative x is negative the sine of x. So when I bring that negative out in front, times that negative 2, it's actually going to become positive. So this is actually going to be 2 sine of 2x times the sine of x minus the sine of 2x. And now I have two things being added together, but they have a common factor. So I'm going to factor out that sine of 2x, and I'm going to be left with 2 sine of x minus 1. Setting this equal to 0 to find my zeros, I see that the sine of 2x is going to equal 0, and that 2 times the sine of x minus 1 equals 0. Again, when I go ahead and solve this, when is the sine equal to 0? 2x is going to equal 0 plus pi n. So x equals pi over 2n. When I solve this one, I have that the sine of x equals 1/2. And when does that happen? Well, that happens at pi over 6. And then I have to go around the circle a whole another time. So pi over 6 plus 2 pi n. It also happens at 5 pi over 6 plus 2 pi n. Now, we need to find when those occur from negative 2 pi to positive 2 pi. Well, if I multiply pi over 2 times negative 4, I get negative 2 pi. That's right there. If I multiply it by negative 3, I get negative 3 pi over n. Sorry, negative 3 pi over 2, which is going to occur right there. If I multiply it by 1, negative 1, I get negative pi. I'm sorry, that's negative 4. Multiplying it by negative 3. Getting to negative pi is multiplying it by negative 2. Multiplying it by negative 1, I get negative pi over 2. It's right there. When I multiply by 0, I get 0. When I multiply by 1, I get pi over 2. When I multiply by 2, I get pi. When I multiply by 3, I get 3 pi over 2. And when I multiply by 4, I get 2 pi. That takes care of the one set of solutions. Now I'm going to look at pi over 6. Well, obviously, if I, not obviously, kind of obviously, it's at pi over 6. If I add 2 pi, I'm going to be beyond 2 pi, but if I subtract 2 pi, I'm going to be at negative 11 pi over 6. So that's going to be there and there. And then finally, 5 pi over 6, I have that x equals 5 pi over 6. That's going to be right before pi. And if I subtract 2 pi, I'm going to get negative 7 pi over 6. So just on the other side of negative pi. And that is my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 solutions. If you have any questions on section 7.5, again, I look forward to seeing you in class.